This is the overview of our system. It is basically divided in three sections. One is leaf node section, another one is base node section, and third one is the server section. At the leaf end, the sensors are connected. The four sensors which we have used are rain, temperature, moisture, and light. The leaf nodes are connected in star fashion. At base node, the data is received via Zigbee, which is then sent to RPi through Arduino. At base node, we have many other features also. One is the actuation feature, which is which makes the motor run automatically based on the moisture value sampled. Another one is the GSM module, which tells the farmer about the different field conditions. And we also have an LCD which is interfaced with RPi, on which the data of all the sensors are displayed. And the last one is the server, on which the fuzzy logic runs. Basically, the RPi communicates with the laptop, which acts as a server, and all decisions are made by this server. So this is the end node setup, which we have shown in the overview. This is the leaf node 1 and this is the leaf node 2. Now the leaf node consists of four Duracell batteries, which gives 6 volts power, and this is the Zigbee, which will send the data to the base station. Now this node has two sensors connected to it. One is the moisture sensor and other one is the rain sensor. Now the other leaf node consists of again two more sensors. One is the temperature sensor, that is LM35, and other one is the light sensor. Now the two nodes which I have explained, they are in star topology, and both the leaf nodes have XB in it. The XB runs in sleep modes. Now because of the sleep modes, the battery life extends to 2 to 3 years. So this is the good feature which we have kept in our leaf node.
Now I'll be talking about base station and GSM. Our base station comprises of Arduino, Raspberry Pi, which is connected to a monitor. Arduino comprises of GSM and Zigbee. As shown over here, Zigbee receives wireless data from the two nodes, which is sent to the Arduino, and Arduino transmits the data serially to the Raspberry Pi. At Raspberry Pi, we have a Python script running which forms the GUI. This GUI displays data from various sensors such as temperature sensor, light sensor, rain and moisture, and a decision in terms of all this is also displayed. For example, the temperature which is shown to be 27 degrees Celsius is found to be normal. Light sensor giving a voltage of 2.89 volts shows a decision of night. Rain sensor giving 3.3 volts indicates no rain, and moisture sensor giving 2.2 volt indicates high moisture. In addition to that, we also indicate the received signal strength from the two nodes and the status of the motor. Now we will demonstrate the variations in light sensor. Initially giving a voltage of 3.15 volt, the decision is night, but now allowing light to fall on the light sensor, we will observe variation in the reading. Now for the light sensor, we can observe that for a voltage of 1.3 volt, the decision is afternoon.
The actuator node. The actuator node consists of a submersible motor, and this is the tank, temporary tank which we have kept. Other one is this is the field, and these are the drip pipes. Now what happens is that whenever I try to lift the moisture sensor, now the moisture is very low, so you can see that
the motor has turned on and the water is coming out of it. Now again when I try to make the moisture high, it will stop. Now it stopped. This can also be observed on the screen. Initially, the moisture sensor at 2.7 volts gives high moisture, so the motor status is off. But now, when the moisture sensor is removed and a low moisture is caused, motor is turned on and the reading is also changed. So the decision would also be changed. When the motor is turned on, a message is also sent through the GSM shield to the number fed into the system. This can be observed as shown over here.
This is the server end of our system. The decision making ability is done by fuzzy toolbox, which is in MATLAB. This is one of the files for decision making. Here at the input side we have the measured values of nitrogen, phosphorus and potassium, and the output is the amount of fertilizer to be added. Now we will see the rules which relates the input and output. The member function which we have used at the input side and output side are Gaussian shape. Now as the quantity of nitrogen is reduced, the amount of nitrate of soda fertilizer to be added is more. So based on the quantity of nitrogen, phosphorus and potassium, what amount of fertilizer we have to add is indicated over here in figures. The unit for the same is ounces per 100 square feet. Now the content which we have measured, the measurement of the content will be done by a soil testing kit, which is as shown here. The amount of phosphorus, nitrogen, potassium and the pH value can be measured using this soil testing kit. Here it is indicated in 5 levels, that is no depleted, deficient, adequate, sufficient and surplus. Another such decision making file is as shown over here. Here the inputs are from the sensors, that is moisture sensor, rain sensor and the type of soil where the farming is done. The output is the sprinkling mechanism and the GSM module from which the message can be sent. The rules for this system are as follows. With the variation in moisture level, the sprinkler can be turned on and off. Now based on the soil type, the amount of water to be sprinkled is decided. Here as we move from left to right, the soil type of soil changes from loamy to clayey. As the clay type of soil holds more water, the amount of water to be sprinkled is less as compared to loamy soil. Also based on the type of rain, that is it is heavy rain, no rain, the amount of water to be sprinkled varies.